Section 6.7 is dealing with what's referred to as inverse functions, and as the paragraph states here, it says if a relation pairs element A of its domain to an element B of its range, the inverse pairs B with A. So that just explaining that real quick. Of course, I'm just using A and B to represent two things, okay? So you've got a relation and A and B are paired with each other. Now, a lot of the things that we're going to be doing that are paired are like ordered pairs. So you can kind of think of your A and your B as kind of like an X and a Y in an ordered pair, okay? So you've got an ordered pair, you know, you've got the X value, you've got the Y value. If you're asked about finding the inverse, then it just switches, okay? So that would mean like your X becomes your Y and your Y becomes your X. So they refer to A and B, and then the inverse pairs B with A. It's, like I said, it's just simply switching it, okay? And that's what the last sentence there states. So if you have the ordered pair AB in a relation, then the ordered pair BA is an ordered pair that's in the inverse, okay? So just remember that your X and your Y, or your domain and your range, switch whenever you're dealing with an inverse. Now, this last sentence here just has to do with notation. The inverse of a function f is denoted by, and it's just like you're putting an exponent of -1, except you don't read it the same way you read an exponent. Two ways you can say it. You can say that this is the inverse of the function f, or you can just say that it's f inverse, okay? Okay, so you're given a table here, and these ordered pairs are part of a function, okay? And it wants you to find the inverse of this function, and then also to do the graphing. Now, to make a table, that's going to represent the inverse. So this is like your original function, and this is going to be your inverse, okay? All you have to do with your ordered pairs, as it stated, was just to switch them. So instead of the 0.10, you would have 0, 1, and then you would have 1, 2, 0, 3, and then 2, 4, okay? So it's wanting you to graph the original relation, and then it also wants you to graph the inverse, okay? So of course the original relation were the 4 that I gave you, okay, this table. So if you plot these points, so 4, 2, you would have those. That would be the original function, okay? Now we're not connecting these up because this relation consists of these 4 ordered pairs, and that's it. So this relation is just points. We don't actually include the points in between by connecting them. So then the inverse, if you plot these points, then these 4 points would represent your inverse. I mean, it's just that simple. If you know those ordered pairs, that's simply all that you have to do is just switch them, okay? Now, you're not always going to have just ordered pairs, and what you're going to see on these next couple of examples is you're actually just going to be given an equation, okay? So you're asked to find the inverse, and then again here it asks if the inverse is a function. This is not something that you're going to have to worry about when you do your homework, okay? I just want you to be able to find the inverse. This is the 2 steps that we're going to go through. You're going to switch X and Y, and then you're going to solve your equation for Y, okay? Now, my first example, of course, this equation's already solved for Y. Most of the time they are, but you're going to start by switching X and Y. So that just means you change this to an X and you change this to a Y. So I would have X is equal to 4 minus 3Y. Now, step 2 is to solve for Y, which means you just need to go back through the necessary steps to get Y back on one side by itself. So first step would be to subtract your 4. And the next step would be to divide by -3. And this is what would be referred to as your inverse. I mean, I know when you're working it out, it's in terms of x and y, but this is equal to the inverse, therefore you can use this notation to state that this is equal to this, okay? All right, next example. Okay, again, you're going to start by switching x and y. So I would have x is equal to y minus 8 squared. All right, so now I've got to work on getting y by itself. Now, since y is inside the parentheses to the second power, the first thing that I've got to do is get rid of the second power, which is going to require that I take square root of both sides. Now, if you take the square root, remember, of something that's squared, those two things just undo each other, which means all I'm left with is just y minus 8, okay? Now, square root of this, so that would give me plus minus square root x. Remember, if you take the square root of both sides, you're always supposed to put plus minus, okay? And then last, to get y by itself, add your 8. So you'll have plus minus square root x plus 8 is equal to y. So this would be your inverse function for this example. Okay, now this is very similar to the first one that I did a while ago. It's just you're not given the table this time. They're just simply going ahead and giving you the function. Now in this case, you've got multiple points because since we've connected these up, you know, you've got point after point after point in between. But we can graph the inverse just by simply using these 3 points, okay? So this is my original function. Remember, this is f, okay? So let's just start with this point. This is the point 0, 4. Okay, so if this is the point 0, 4, then on my inverse, I would have to have the point 4, 0. Okay, so let's plot 4, 0. Okay, this point is the point -2, +1. So my inverse would have to have 1, -2. Okay, and then this third point, that would be -4, +4. So now I need to plot +4, -4. And then just make sure when you connect this up that you connect it up the correct way. Now, you've got 3 points, so you could connect up and make a V several different ways. Okay, now here's what I want you to remember that will help you remember sometimes how you need to connect these up. If you took the line that cut these 2 quadrants, like if you cut quadrant 1 and quadrant 3 perfectly in half, you are supposed to be able to take this image, fold it across, and like this one is supposed to land and be on top of this one. Okay, so like in reference to my red line, I'm supposed to have a mirror image. So in order to make that mirror image, you know, like I couldn't make my V any other way, or I wouldn't have that mirror image.